because when you decided to start talking, you had not heard the person. They decided at the same time, but you don't hear decisions that make in your head. Once you start talking, that's when you realize that somebody else is talking. So in network sense, two nodes sense the channel is idle, start transmitting, and after they start transmitting, they receive the other signal. Okay? So here in this picture, this is a spatial layout. These are physically, these stations are in a line, stations A, B, C, and D. Okay? And the time is along this axis. So here at time t0, B sees nothing, channel is empty, everything is good, let me start broadcasting. Okay? So the signal starts traveling along the wire. These are very tiny intervals. We are talking about transmission or, the propagation time of the signal. And maybe a few nanoseconds later, T1 decides the channel is empty because it has not heard B yet. As far as T1 is concerned, everything looks good. So T1 starts sending, and then a very small interval of time later, that's somewhere here, okay, at the green spot, the D starts getting the signal from B. Okay, now it's known that their message is doomed. Okay, and at D, at the blue spot, as you go down time, at this point, it gets the signal from D. Now it knows also that its transmission is doomed too. However, we just keep sending until you're done with data, but at the end of it, at least you know it was a failure and you can try again. Okay? So you need to, we are not talking what do you do when you have a collision, but that's how collision happens, and you detect it when you get a signal from the other side. So remember, this is very closely related to distance and propagation delay. If things are really close, collisions are very unlikely because this time interval is really small, while if there's a long distance, it's a long time before you figure out that somebody else is sending. So the next question is, we want to improve this, and there's an obvious way to improve, which is, at these spots, the blue and green spots, when D already knew that this message is corrupted, there's no real reason to continue with the transmission. Likewise, at blue point, the B already knows this message is going to get corrupted. There's no point continuing. So this was sheer waste that could have been avoided. So you can fix that. So the way you fix it is that the moment you have the signal, you start sending, here you figure out that your signal is corrupted, and then it takes you a little bit to, if your antenna or signal this thing, to kind of realize that and take action. But you take action, and at this point you stop sending. Okay. Likewise over here, then yellow realizes here that it's bad. It takes it a little bit time, or the detect/abort time, and then they stop sending. So they're wasting much less time than before by continuing to send the whole thing. So let's wrap this up here. So first one was CSMA protocol, which is carrier sense multiple access. Carrier sense means that you're looking at the carrier before you start sending. Okay. The second one is CSMA CD. Same CSMA, carrier sense multiple access /CD means collision detection is also part of it. So we've gone from here. There's no sophisticated collision detection. You do detect collisions, but you do nothing about it. And when you actually react to collisions quickly, that's officially CD collision detection. So collisions are detected quickly in CD anyway, and yeah, the colliding transmission is aborted as soon as possible. So now the question is, when and why would you want to use CSMA and CSMA CD? It looks like the collision detection is a good idea. Looks like you should always do this. However, detecting collision is not that easy in some situations, especially in wireless networks. So you will see that sometimes you have 20 nodes, there is a collision, some nodes detect it, other nodes don't because of variety of reasons. So in general, you just use the basic CSMA in wireless networks. However, in a wired network, detecting collisions is really easy because the flow of the current is much more predictable. So you know exactly when a collision happens, and so you are better off using CD. You have collision detection, you use it. Okay. Okay, we have one more protocol, but we're out of time, so I'll stop here. Any questions on CSMA? By the way, these are the protocols. This is very close to what's used in real life in Ethernet. So, and next chapter, or sorry, next class, we will also look at Ethernet and real life protocols. Okay, thank you.